AI data and machines in sync. Innovations here faster than you think. Industry 4.0, the future's arrived. Smart solutions where ideas thrive. The Graton song for a podcast intro. At the end of fun should decrease step by step.
All right, everyone, welcome in. Today's deep dive takes us right to the factory floor. But hold on, we're not talking about heavy machinery, at least not directly.
That's right, we're going deeper, to the software that makes all that industrial automation tick. Specifically, IEC 61499.
IEC 61499, the talk of the town. Some say it's the future, others, well, not so much.
And we're diving into a mountain of research to see who's right, or at least who might be closer to the truth.
So for those who haven't encountered the standard yet, what's the big deal with IEC 61499? Why all the buzz?
It's about control, really.
Yeah.
See, for ages, IEC 61131 has been the go-to standard for programming these industrial control systems, the brains behind all those automated processes.
But now, like with everything tech, things are evolving.
Exactly. Factories need systems that are more flexible, adaptable, and, well, smarter.
And IEC like 61499 swoops in with promises of, let me see, portability, interoperability, configurability music to any engineer's ears, right?
Sounds almost too good to be true, doesn't it? But those terms, they're not just buzzwords. They represent some fundamental shifts.
All right, break it down for us. Let's start with portability. Does that mean I can just pick up my code and...
Well, not quite pick it up and walk it over, but close. Imagine writing code once and being able to use it on equipment from different manufacturers without any major rewrites.
Okay, now that would be huge for saving time and resources. No more wrestling with proprietary systems.
Exactly. It's about making automation more streamlined, more efficient.
And what about interoperability? That one always sounds a bit like a magic trick to me.
It's about getting different devices, different systems, to talk to each other seamlessly, like a universal language for the factory floor.
So no more silos of information, everything working in sync.
Precisely. That's the idea, at least.
Now, one paper went as far as saying IEC 61499 could lead to autonomous reasoning and even negotiation between devices. I mean, are we talking about robots having board meetings here?
Well, maybe not board meetings, but the concept is that devices will be able to make more decisions on their own based on real-time data.
Instead of just saying, hey, something's wrong, they'd figure out solutions, adapt on the fly.
Think of a sensor detecting a production bottleneck. With IEC 61499, it wouldn't just flag the issue, it could trigger a series of actions to reroute materials, adjust speeds, all automatically.
Okay, fewer headaches for the humans, I can see the appeal. But this whole shift from cycle-based to event-driven, that's a big part of how this works, right?
It is, and it's a fundamental change. Imagine a security camera that's always recording versus one that only kicks in when it detects motion.
Much more efficient, less wasted storage.
Exactly. And with IEC 61499, instead of constantly monitoring everything, the system focuses on reacting to specific events, which makes it much faster and more responsive.
Okay, starting to get the picture. But while this all sounds fantastic in theory, I'm noticing some skepticism in these papers. Some even call the standard ambiguous and question if it's living up to the hype.
Well, standardizing something as complex as industrial automation software, it's a huge task.
I can imagine lots of cooks in the kitchen, so to speak.
And that can lead to different interpretations, different approaches, which can create ambiguity in the specifications themselves.
Right, and one paper even pointed out potential performance issues with XML, even though it's praised for its open format in other papers.
It's a classic trade-off, openness versus efficiency. XML is great for flexibility and interoperability, but it can be demanding on resource-constrained devices.
So it's not a one-size-fits-all solution, more like finding the right tool for the job.
Absolutely. Understanding the strengths and limitations is key, just like with any technology.
Well said. So we've got all these promises, some skepticism, but what about real-world applications? There's got to be some examples of IEC 61499 in action, right?
Oh, absolutely. One fascinating case study focused on using IEC 61499 for an airport baggage handling system.
Oh, wow. Now that's a system that needs to be adaptable and efficient, if I've ever heard of one.
Right. And the study looked at how IEC 61499 could handle the complexities of coordinating all those subsystems check-ins, screening, sorting, and how it could respond to different events, like, say, a sudden influx of passengers.
Or a jammed conveyor belt, or a misplaced suitcase causing chaos. Yeah, I can see how that would be a good test for IEC 61499.
Exactly. It's about creating systems that can handle the unexpected, and those real-world applications are where we see whether it truly delivers.
All right, so we're starting to see how this all comes together, but there's still so much to unpack. We'll dig into more of those fascinating case studies and the potential impact of IEC 61499 right after the break. And we're back, diving deep into the world of IEC 61499 and exploring its potential to, well, maybe not quite take over the world, but definitely shake things up in industrial automation.
It's about more than just factories, though. One study looked at using IEC 61499 for something completely different: smart grids.
Oh, interesting. So instead of just keeping the lights on, it's about making the entire power grid more intelligent, more responsive.
Exactly. Imagine a system that could predict and prevent blackouts, optimize energy distribution based on real-time conditions.
That's some next level stuff. But let's get back to those factories for a second. What about companies that already have systems in place based on the older standards? Is it a smooth transition to IEC 61499 or more like starting from scratch?
Migrating legacy systems is always tricky, right? It's doable, but one paper described converting existing code to IEC 61499 as being like, well,
Like trying to fit a square peg in a round hole.
it's more like translating, say, a novel into a completely different language. You need someone who understands not just the words, but the nuances, the style, to make it work.
So not impossible, but definitely requires expertise, careful planning.
Absolutely. And even then, there might be some compromises, some things that don't translate perfectly.
Makes sense. Now, one thing that's got me curious is how IEC 61499 handles more complex tasks. We've talked about adaptability, but what about things like intelligent agents, self-healing systems? Are we getting close to AI territory here?
It's a blurry line, for sure, and one that's constantly shifting. But we are seeing a move towards systems that can monitor their own performance, diagnose problems.
So not just reacting, but anticipating.
Exactly. One study even created a self-healing system for an industrial robot using IEC 61499.
A robot that can fix itself, sign me up. But seriously, how does that even work?
Well, they were able to design the system so it could detect anomalies in the robot's movements, identify the cause, and even adjust its own control parameters to compensate, all in real time.
Wow, that's impressive. But all this interconnectedness, all this autonomy, it makes you wonder about security. I mean, what's to stop someone from hacking into these systems and causing chaos?
You've hit on a critical point. As we move towards more intelligent, interconnected systems, security becomes absolutely paramount.
No more duct taping a firewall onto the network, huh?
Not quite. The research emphasizes a multi-layered approach: strong authentication, data encryption, intrusion detection.
So building security into the foundation, not just adding it as an afterthought.
Right. One paper even suggested using blockchain technology with IEC 61499 to create tamper-proof logs, making it much harder for malicious actors to cover their tracks.
So a digital trail that's almost impossible to erase, that's reassuring. But with all this sophistication, all this complexity, is there a risk that IEC 61499 could end up being accessible only to the big players, the ones with tons of resources?
That's a valid concern, and it highlights the importance of making IEC 61499 more user-friendly, more accessible to everyone.
Democratizing industrial automation in a way.
Exactly. Several papers advocate for things like open source libraries, pre-built function blocks, intuitive visual programming interfaces, tools that would empower anyone to design and deploy these systems.
So not just relying on expensive proprietary software and armies of programmers.
Right. The goal is to make this technology accessible to startups, small businesses, anyone with a good idea.
That's encouraging. But speaking of making things easier, one paper mentioned the need for more consistency in testing and evaluating IEC 61499 implementations.
Ah, yes, the challenge of standardization. It's one thing to have a standard, it's another to make sure everyone's implementing it in a way that's, well, standard.
Because otherwise, it's like comparing apples to oranges. You never know if you're really talking about the same thing.
Exactly. So one solution is to develop what's called a compliance profile, a set of guidelines and standards that all implementations must adhere to.
So like a universal rule book, making sure everyone's playing by the same rules.
Precisely. That way we can compare different systems, different approaches, and make informed decisions.
That makes sense. Now, amidst all the technical details, one concept really jumped out at me, the idea of using design patterns in IEC 61499 programming.
Ah, design patterns. Think of them as blueprints or templates for solving common problems in software design.
So instead of reinventing the wheel every time, you've got these pre-built solutions, best practices, ready to go.
One paper gave the example of a generic actuation module that could be configured to control different types of actuators, like motors or valves.
So it's like having a library of Lego structures. You can use them as is or modify them to fit your needs.
Exactly. It's about making development faster, more efficient, especially for those who might not have the resources to start from scratch every time.
This could be a game changer, especially for smaller companies. But if design patterns are so useful, why aren't they more widespread in IEC 61499 development?
It's still early days, to be honest. The field of design patterns for IEC 61499 is relatively new, and there's no agreed-upon catalog of patterns.
So it's like we're still figuring out the best way to organize the Lego instructions.
Exactly. But as the IEC 61499 community grows, we'll likely see more standardized design patterns emerge, along with tools and resources to make them easier to use.
It's like we're building the plane while we're flying it, which is both exciting and a little bit terrifying.
That's the world of emerging technologies for you, always evolving, always pushing the boundaries, and IEC 61499 is right there on the cutting edge.
So we've covered a lot of ground here, from the nitty-gritty technical details to those futuristic self-healing robots. But let's zoom out for a minute, big picture time. If IEC 61499 really takes off, what kind of impact could it have on, well, everything?
That's the million-dollar question, isn't it? Technology rarely stays confined to its little box.
Right, it ripples out, changes the game. And one paper made a really interesting comparison talking about IEC 61499 and the rise of, get this, open source software.
Now that's an intriguing parallel. Imagine that same spirit of collaboration, that open sharing of knowledge and tools, but applied to industrial automation.
Instead of everything being proprietary, locked away, it's like this shared pool of innovation. Anyone can jump in.
Exactly. Engineers sharing their IEC 61499 function blocks, creating open source libraries of applications.
So a small startup with a good idea wouldn't need a massive budget to develop sophisticated automation solutions. They could build on what's already out there.
Precisely. It could level the playing field, foster a whole new wave of innovation.
That's exciting, but, and I hate to be the voice of doom here, but could that kind of accessibility have downsides?
Of course, every technology has two sides, and the research does acknowledge those concerns.
Job displacement, for example. If machines are doing more, what happens to the people?
It's a valid concern.
Yep.
But one study argued that rather than just eliminating jobs, IEC 61499 could create new opportunities.
So it's not about replacing humans, but changing the nature of work itself.
Exactly. We'd need new skill sets, a greater emphasis on things like critical thinking, problem solving, working alongside intelligent machines.
It's like instead of turning the gears ourselves, we're designing the gears, optimizing the whole system.
Precisely. It's a shift in mindset, a shift in how we approach work itself.
So for anyone listening who's feeling a bit overwhelmed, maybe even a little scared of these changes, what's your advice? How do we prepare for a future where automation is everywhere?
Embrace curiosity. Don't shy away from these advancements. Dive in, learn, adapt.
Easier said than done sometimes, but I get it. The world's not slowing down. Got to keep pace.
Exactly. The world of technology is constantly evolving, and IEC 61499 is a prime example of that.
It's been fascinating, eye-opening, really. So, to wrap up our deep dive into the world of IEC 61499, it sounds like we're left with a sense of cautious optimism, wouldn't we say?
Absolutely. There are challenges, no doubt, but the potential is enormous.
It's a powerful reminder that technology is a tool, and it's up to us to decide how we use it.
Well said. And who knows what incredible innovations await us just around the corner.
A big thank you to our expert for guiding us through this complex and ever-evolving landscape. And to our listeners, thank you for joining us on this deep dive. Until next time, keep exploring, keep questioning, and most importantly, stay curious.
Welcome to the future, Industry 4.0. Tech revolution, automation's the show. AI data and machines in sync. Innovations here faster than you think. Industry 4.0, the future's arrived. Smart solutions where ideas thrive.